Fuzzing is a technique that let development teams and security analysts exercise their protocol systematically by generating millions of random tests and testing against the specification. And if at any point the fuzzer finds a violation to any of its inputted specifications, it will generate a counterexample for the development teams or the security analyst that uses the fuzzer. And since this is a testing technique, it doesn't mean that if the fuzzing campaign finishes and the tool doesn't find any vulnerabilities, that the code base is absent of any bugs. It simply means that for the time that the fuzzer ran, it didn't discover any vulnerabilities. So the takeaway here is that the longer you run a fuzzer, the more probability you get in discovering a bug if one exists, or the more coverage you get for the existing protocol. OrCa is a very easy tool to set up. All you need to set up OrCa is a deployment script so OrCa can deploy the protocol on a local chain or an existing deployment on any chain. And a set of specifications written in our language called V, which gives you a way of declarative describing the expected behavior of your system and avoiding having extra footprint in your code base just to use a fuzzer. So once OrCa has these two components, it will start randomly executing the protocol with arbitrary input and constantly check if it found any violations. And in the case where it found a violation, it will return a test case where the user of OrCa can inspect and see what went wrong with their protocol. Post-deployment fuzzing is really important because, as I mentioned earlier, fuzzing is essentially a testing technique. What is important is to explore as many states of your protocol as possible. So during development, this is essentially coming mainly for the existing test of the protocol or how you set up your deployment script. However, once you have an actual deployment and real users start using your protocol, they can lead you to more realistic regions of the overall states that your protocol can reach. So then OrCa can start from a realistic initial state where the protocol is being used by actual users and then start fuzzing in order to find vulnerabilities that are more likely to happen in a real world deployment. After the audit ends, what a developer or a security team needs to do is provide AuditHub the deployed addresses of the protocol, along with either the code base or the ABI of the protocol. And then the regular checkpoints, OrCa will fork the blockchain that the protocol is deployed locally, and it will start executing a fuzzing campaign as described earlier. And if OrCa finds a bug, at that point, it will notify the user in a similar manner as all of our tools, notify our users when a bug is discovered. And this is very important because instead of waiting for a bug to happen on chain, we proactively check for bugs as the protocol being used in the wild.